Welcome everyone to tonight's session of Soil School. I'm Renee Magyar with West Multnomah Soil and Water Conservation District. And our mission is to provide resources, information, and expertise to inspire people to actively improve air and water quality, fish and wildlife habitat, and soil health. We serve residents of Western Multnomah County, Soviet Island, and a portion of the Bonnie Slope neighborhood with conservation planning, weed management, native plants, wildlife habitat restoration, and school and community gardens. And we're co-hosting this webinar series with our partner, Tualatin Soil and Water Conservation District. And their mission is to create a sustainable, productive, and healthy environment for the Washington County, Oregon community. They serve residents of the county by providing educational opportunities, advice about natural resource conservation, and financial assistance for conservation projects. And we are here today to talk about the basics of soil health. And as we discuss this important topic, it's important for our district to acknowledge the original stewards, the indigenous people of the land where we now provide conservation services, and their deep and extensive knowledge of this land. We honor all tribes on the lands covered by the participants in this far-reaching workshop and beyond by committing to work with their descendants and learn from their traditional ecological knowledge and relational worldview of the land and all living things upon it. We further recognize that we're here because of the land displacement, attempts at cultural erasure, and other sacrifices that were forced upon them. We also remind ourselves that we are guests of this land and must do our best to honor the original peoples through authentic cultural narratives and continued caring of and giving to the air, water, plants, animals, soils, and the ecosystems that make up this land community. So I have a few housekeeping tips for you tonight for the session. We're recording all of the sessions of Soil School, and they'll be available on Tualatin's YouTube channel by the end of the month, maybe a little bit sooner, but best to check at the end of April to be sure. And I believe also the recordings will be available, links to the recordings will be available on the event registration page at the end of the month as well. So tonight we have a 50-minute presentation and 10 minutes for Q&A at the end. So please put your questions in the Q&A window and not in chat. We won't be monitoring chat for questions, but only for if you have problems, something like that with your video, audio, things like that. Or if you wanted to just chat amongst each other, amongst yourselves. So let's see, we also have, if you see a question in the Q&A window that you like, you can upvote it by clicking the thumbs up icon in the Q&A window. That will help show which questions are most interesting to be answered tonight. We might not be able to get to all of our questions, though we'll do our best. And we'll also be sending out a link in a moment in the chat to a survey. We definitely want to know what everybody thinks about tonight's session. So we'll be posting that in just a moment. And now I have the honor of introducing tonight's speaker, Katie Chambers. Katie is a resource soil scientist with Natural Resources Conservation Service based in Salem. And in this position, she provides regional technical guidance for natural resource management, Farm Bill compliance, and she is a resource for information about soil in Western Oregon. Prior to this role, she worked as an NRCS soil scientist in Klamath Falls, and also has worked with the Forest Service and at a private strawberry nursery. One of Katie's favorite endeavors is talking about soils and educating people about the world beneath our feet. So we are delighted to provide the opportunity for Katie to do what she loves best. Take it away, Katie.
Thank you, Renee, for that introduction. I just want to say how excited I am to be a part of this first. This is my first soil school, and I'm also really excited that you're here to learn more about soil health and soils. I think you might have learned from James Cassidy on Tuesday about how soils is everywhere and how it impacts our lives. So throughout the presentation, if you think of different ways in which products that you have come in contact with that don't have a relation to soil, I personally can't think of anything in my life, and I'm just curious if you guys can think of anything. And then we can review it when we get to the end. But I have a lot of information to share with you, and I hope you find it interesting and that you learn more about soil health. So with that, the objectives is why to incorporate soil health into your management practices, and how soil health principles can impact your management decisions, as well as how to implement soil health principles. The soil health principles, 4 main principles are maximizing living roots, maximizing diversity, and minimizing disturbance and maximizing cover. These 4 principles help support high functioning soils. You may be wondering, what do I mean by functioning soils? Soils, you might have learned in other classes about how soils, what soils are and where maybe they are at on the landscape. But what soil function is what soils do. So what we want our soils to do for us. And we all have different expectations for soils, but here are some important soil functions that I'm going to talk about. Supporting productive plants. We all want healthy plants. That's why we do gardening and agriculture in general. We want our plants to produce delicious foods or even beauty. I just went to the Tulip Festival in Woodburn, and it was really a beautiful sight to see all those different colors and those healthy plants. We also want our soils to stay put. We don't want them to erode away. We want them to be stable. We want the inputs that the love that we are giving to our soils to stay where they're at and not become into our watersheds. We also want our soils to cycle nutrients efficiently. But we also want our soils to absorb that water and infiltrate the water quickly, as well as drain away so that we can produce these delicious plants and the productive plants. And unless we want a wetland, which I'm all for wetlands. And we also want our soils to store enough water for the plants to use, but not too much water. We want our soils to be resistant to diseases and pests and pathogens. We also want our soils to be able to withstand stressful events. Last year when we had that heat dome, having healthy soils could give those plants a little edge on situations on those stressful events. I think we all felt like we were melting. But what is all these things have together? How we get these functions is biology. It's the biology within the system and how the biology works with the inherent properties of the soils that make the soils more functional. And I know this is a broad term as well, but what I'm really talking about is the food web. When you were in elementary, or maybe your children learned this in elementary, or are learning it currently, or that above ground food web of how the grass provides the mouse with food, and then the mouse becomes food for the hawk. But the food web is much deeper than that. And I completely intended that pun, where the soil food web is really what I'm talking about. And the soil food web provides, if it's healthy, the next trophic levels above the ground are going to be healthy as well. Here is an image of the soil food web that I find is very beautiful. It's got all these different these organisms as depicting a very robust system. You have nematodes and bacteria and ant colonies. All of these organisms have a function and are contributing to the ecosystem under our feet. And there is one particular the energy that is provided by our sun, combined with the carbon dioxide, allows our plants through photosynthesis to build their bodies. The carbohydrates as well as the simple sugars help build their leaves, their blossoms, their stems, but it also helps them build their roots. And also there's another source that they dedicate some of that material, that carbon is to the exudates of their roots. And the reason why they do that is to attract different microorganisms that will help them uptake nutrients that they need. And each one of these plants will have a different type of carbon that they produce, or different kind of carbon molecules that they produce that will attract different microorganisms. So then it's even more diverse. The soil organisms that within the soil food web, there are three broad functional categories that we can divide the organisms into, which is the biochemical engineers, as well as the biological regulators, and the ecosystem engineers. These organisms have evolved over hundreds and millions of years to have these mutualistic relationships, as well as a predator and prey, and they keep each other in check, as well as help each other grow and help an ecosystem that will be sustainable. I'm going to go through each one of these, but not in super detail, because I realize that you have some panelists in later this month that is probably going to go really in depth with this, and I'm just going to touch the surface. But I'm going to start with the biochemical engineers, and these are the bacteria, the soil microbes, the things you can't see other than without a microscope. And they're one of the most important microorganisms, or important organisms, because they're the ones that are attracting all the other critters, all the other soil microorganisms to the roots and causing the soil food web to function. They regulate 90% of the energy within the soil. They also help with creating aggregates. And as I explain further in the presentation, you'll see aggregate stability is such a vital role in soil function. And they also help produce organic material, as well as they cycle nutrients. While I was doing preparation for this presentation, I came across radiotrophic fungus. And this is kind of a little bit of a tangent, but they would be part of the biochemical engineer group, but they were discovered in 1991 in the Chernobyl nuclear power plant. These organisms are not only surviving, they're thriving in an environment that they would normally not be, that you wouldn't think that they could. But instead of using solar radiation, they're using ionized radiation to fuel their energy. And they use melanin instead of chlorophyll to help process those sugar to survive. So my point of this slide is that biology is resilient, and this point will come up in the future, or in later in the presentation. So if you kind of think about those microorganisms as a little bag of fertilizer, the biological regulators are the organisms that have them for dinner and they use their bodies for their energy, but then they exude those nutrients that are vital for plants to be able to access for their bodies and to be able to be healthy and resilient. And they also help mineralize the nutrients that way. They also regulate the different populations so that one population doesn't become abundant over another in a healthy ecosystem. Now you have the ecosystem engineers. Now these guys, like if you took the time ever in the past to just, or maybe you will in the future, of sitting at a park bench over the grass and seeing and just kind of staring at it. Or maybe it was your lawn or the forest or even your garden. And you can just start seeing, after you looked at the ground for a while, it moving. These are the ecosystem engineers. These are the ones you can see. And these are called ecosystem engineers because they are building these houses of their own. They're engineering, kind of like how beaver are ecosystem engineers, that they build their dams to hold water. These guys are building pore spaces. And it's the pore spaces within soil that where life happens. It is very vital for water infiltration as well as nutrient cycling. So by managing your soils for health, you are considering, it equals considering biology for the function of everything you do. And by combining the solar radiation and the carbon dioxide in the air, plants utilize through photosynthesis, build their structure. And some of the presentations I've seen by other soil scientists have referred to the sugars that plants exude out of their roots as donuts and cookies. And I started thinking, like, what does my sweet tooth prefer? And I like saltwater taffy. I like saltwater taffy because there's so many different colors and there's so many different flavors. And that seems to be such a great analogy because these plants produce different flavors and different color, or different, maybe not colors, but different flavors of sugars to attract different organisms. And then if you think about organisms as your livestock, they're feeding on the saltwater taffies. And then you have different types of livestock coming in. And if you take care of your soils as if it was livestock, for an example, you wouldn't just go get chickens and then at the end of fall, you say, well, I'm not going to feed you anymore. And you wouldn't have any chickens in the spring. So by thinking about your microorganisms as livestock, you're feeding them constantly 24/7. That's just kind of a goofy analogy, but livestock eating saltwater taffy, why not? So have anybody heard about who Hamond Bennett is? He's the father of conservation. He's really the reason why I am here with the soil conservation districts. He was a person that had perseverance, and he was a very observant individual. And early in his career, within 2 years, so his first position after graduating college was working for the USDA. And his second year, he was asked to go to Vermont to check out a field that wasn't producing as well. So he dug a hole and did his observations within the cropland. And his job for those 2 years was mapping soils so he could recognize landscapes. And he noticed that the part of that landscape was actually still a forest. So he went over, dug a hole in that forest soil, same soil, just managed differently. And that soil in the forest was dark and had aggregates and was full of life. And what he was observing that was different than the cultivated soil was that there was habitat being provided to that soil. And not that the conventional farming is bad, it's just that we've learned more since that time, and we are continuing to learn more. And there's been this explosion about information about the soil food web as well as soil biology interaction. And this quote, I feel, is just as important as it was the date when he said it as it is now. If you are bold in your thinking, courageous in accepting new ideas, and willing to work with instead of against our land, we shall find conservation farming and an avenue that is greatest food production the world has ever known. So this story was mostly just about how perseverance of one individual can make a difference, because he helped create a whole movement in his day, but also that he found habitat within the forest. So now I'm going on to explain why habitat in the soil is so important. It provides the house for these organisms to interact and to do the things that they're doing and provide that diversity. This is an image of a root at the very top, and then there's a fine root with root hairs off to the left. And then there is these big boulders, which are actually sand grains, but at this scale, they're a boulder. And then you have some silt particles and some microbial hyphae. But you also have a nematode at the very bottom, surrounded by water. And it's swimming around, doing its thing, eating bacteria for lunch and producing excrement for the plants to uptake those nutrients. And at the very top, you have a completely different habitat where you have this red mite just hanging out in a terrestrial environment. And these are all working together to provide an ecosystem that is robust. And this system can change as soon as you irrigate it, or maybe there's a drought, or maybe there's a rainstorm, or maybe it erodes away. But this system is dynamic and is changing at all times. And this is an important thing about soil, is that it provides habitat to the organisms. But, you know, within the soil, there's hotspots, there's biological hotspots within the soil. So the soil isn't completely uniform of where this activity is happening. It's happening throughout, but there's certain areas, and these 5 areas are analogous to where these more interactions are occurring, such as the pore spaces and the root channels and the earthworms, as well as the aggregate surfaces. I have a demonstration to show you how important it is for aggregate stability. And I have 2 of them. I have to adjust my camera a little so you can see. Okay, so I have these little jars of water, and there's these little strainers. So this one I have to prep first, and then I'm going to put it aside and do the slate test. But the soils I'm going to use are from the Soil and Plants division in Corvallis, and they are a research farm, so they have multiple types of land use. This soil has been under the soil health principles for about 14 years. And this soil has been tilled and disturbed multiple times and probably driven on. And you can kind of tell the difference. There's a bit of a different color change. You can see a lot more roots in this one compared to this one. But I'm going to set the big ones aside. I'm going to use those later. And I'm just going to put these little aggregates in the water and let them soak for a bit. That might be a little too much. Need a little more water in this one. Okay. Okay, I'm going to set these aside. We got too many aggregates in here. Okay. All right. And then I'm going to show you, that's going to soak up the water, and I will come back to those. Next, I have what is called the slate test. Now, this is the soil that had been under soil health principles for about 14 years, and this is the one that has not. And I'm going to just put these in the water. And I would like you to observe what is happening. Can you see that there is a lot more sediment falling out of this one comparatively to this one? So what's happening is that when water infiltrates into the PED or the aggregate, it's creating a pressure. And if that aggregate, that soil is not strong enough to withstand that pressure, it starts breaking apart. And how the soil gets strong aggregates is by the biology. It's by the root exudates, as well as the the microbes producing their exudates, as well as, so there's a lot of coating and carbon that is being stored and gluing these particles together. And as you can see, this one is really taking up speed on falling apart now. And this soil is losing soil. This is how soil erosion occurs, is that the soil isn't strong enough to hold up the water. And all this material, you're losing your fertilizers or your organic material that would be there into the water system, and it's being drained away. I'm going to set these guys over, and as you can see, this one's pretty stopped. It's and then I'll just remove it. I'll just finish this demonstration. Then I'll see like how I just touched it and it just kind of fell apart. This one fell apart a little too, but this one, it's like this disintegrating. Oh, and the other point too is that you're losing all your nutrients right here. So you're not, so it's great to have a stability of your aggregate stability. So I'll go back to the other demonstration, which this one I want to point out. So now they have soaked up water, and I'm going to flop these over. Let them drain a little bit. Here. Okay. Can you see the difference between these two? See how this one looks more like soil brownies, and this one's more like a mud pie. And then look at the water as I tilt this. Watch the water drain. See this, how it's just, but there really wasn't a huge amount of water that drained out of there. So it's holding more water as well because of their organic material. And this is just a mess. So that's my demonstration, and I'll get back to my presentation. Oh, I forgot to unshare my screen. I'm sorry. Could you guys see that very well? Okay, good. Thank you. Sorry, I totally wanted to unshare my screen and show you that, but you got it. So how do the soil aggregates form? Soil aggregation is really where organic material and texture meet. And this is an image that is showing going from macro aggregate 3 millimeters from the left, and then to the right you have your primary particles, and that's 0.003 millimeters. So these are the individual silt, sand, and clay humus material. And I'm going to go through each one of these and give you examples and images. So the primary particles are the images at the very top here of iron oxides. And then here you see that there is a quartz particle, and then you see these clay phyllosilicate clays. And these are all electron microscope images. So what's happening is that these little particles are being held together by by a little bit of organic material, as well as iron oxides and electrostatic forces. But it's not really held very tightly together at this stage. And then as you get more organic material, biological exudates and plants from microbial exudates in plants, it starts taking those primary particles and building them up into a sub-micro aggregate. So the image directly to the left, you can see that this is a submicro aggregate that's electron microscope, and here's a clay phyllosilicate, and then in here you can see the bacteria or the exudates to just kind of gluing that together, as you can see over here as well. This top picture is a sand grain with the biofilm coating it. So these films help hold these particles together. So you have primary particles all over there, and then they're being held together by biofilms. Now we're going to go up one stage to the macro aggregate. And at this stage, you have different fungi and bacteria holding it together, as well as you're getting some fine roots that are starting to bring those subaggregates to making a micro aggregate. And I want to point to your attention to where the nematode is eating soil organic material. It's not necessarily the nematode that I'm really pointing at. It's the soil organic material. Look how flaky and how much surface area that organic material has. That's part of the reason why you have this versus this, because it has so many surface areas that it can absorb it like a sponge. You want our soils to be full of holes like a sponge versus a brick. And then this is the last stage where it's the macro aggregate. So all those micro aggregates are being bound together by different hyphae and fine roots and making more of an aggregate, and a stable one. But aggregation can also be degraded, which I'll get to after this slide. So I wanted to highlight mycorrhizal. So the image on the right is from when I was mapping in Klamath Falls. So that's what you're seeing is a bunch of pumice sands and some small gravels that is from the exudates, or from the pumice zone of when Mount Mazama erupted and now become Crater Lake. Now these soils are so young, they're 7,700 years. So they still have growth, but a lot of the places where there would be any kind of aggregation is because of the mycorrhizal fungi. And then you can see in here the little white filaments. That was the only reason why this soil really had any kind of structure. And why they're so magnificent is that they're also very helpful to our plants. They literally, the hyphae get incorporated into the cells of the root hairs, or of the roots of the plants. And they're able to go and extract nutrients from places that the root hair can't go. And they can bring in phosphorus and water to that plant that they normally wouldn't get. And I kind of think, when I was younger, I used to watch Saturday cartoons, and one of my favorite was Inspector Gadget. So I kind of think of the hyphae as the arms of Inspector Gadget. And this is kind of my analogy, I guess. But there's other aggregation processes as well, such as physical and chemical, drying, wetting cycles, freeze thaw. Fire can also adhere particles together. And calcium and oxide binding agents can also bind particles together. So what I'm trying to do with this slide is to incorporate everything that we've learned so far. That the organic matter really feeds that soil food web, and you need that robust, active, teeming with life ecosystem to help provide that glues and the sugars to be able to make stable aggregates. And so those aggregates can stay together and can provide those functions that we want our soils to do, such as supporting the productive plants, as well as absorbing the water and also helping it to drain away. It's those pore spaces, those spaces between the aggregates and those worm burrows that help the water infiltrate. There is a quote from the basic Soil 101 type book, and it's The formation and maintenance of a highly degree of aggregation is one of the most difficult tasks of soil management, yet it is also one of the most important, since it is the potential or the potent means of influence the ecosystem function. So this quote is really combining how management can provide aggregation, and that aggregation is really what is driving the ecosystem function. But you can degrade these soils, and at some point, there is a lot of people that are working with degraded soils at some level, and it's once you start opening up by tilling, you're crushing those pore spaces. And the intensive tilling can cause soil erosion, and then you're not adding as much residues. And that reaction occurs, and then you have soil organic matter decreases, and then it breaks down the aggregates, and the surface becomes compacted. And when that starts happening, your soil isn't infiltrating, or they're collapsing the pores within it. You're making your soil from a sponge to a brick. So you're not having those spaces as much. And when that aggregate starts breaking apart, these little particles can get caught in and fill in those pores. And then it creates a seal on the top of your soil. And then there's more erosion, because now it's taking away that soil, and it's taking away those organisms and that organic material, which then will lead to crop yield reduce and the hunger and malnutrition. Now, we're not at that stage in Oregon, but it's been time that it's been observed that how we treat our soils is really how civilizations can thrive. This is an article that you can find on the internet. It's by Dr. Lodermilk. He worked for the Soil Conservation Service, and he went and studied different soils that had been, or different cultivation processes throughout the world that had been in agricultural production for hundreds and thousands of years, and made observations. And what he found is that soils that were not taken care of or nurtured for the biology, the civilizations collapsed. But the ones that did were very productive. And this is a very fascinating paper, and I suggest you look it up and read it. It's kind of cool. But so not all is lost. You can build soil aggregation, and you don't necessarily, by having these soil principles, these 4 soil health principles, you can build biological activity, which then can build aggregation and make your soils productive. And that was the why you want to implement soil health principles. Now this is the how. So the maximizing living roots, maximizing diversity, and minimizing disturbance, and maximizing cover. Now, when I'm saying about minimizing disturbance, you're never going to eliminate disturbance whenever we are utilizing the land. It's the thinking about it mindfully of what disturbance you are doing. But there's going to be disturbance. So really what these 4 principles can be divided up into is feeding and protecting, feeding your biology, and having a continuous flow of carbon inputs, as well as protecting that habitat and the soil aggregates and that soil organic matter. So we're going to start with the feeding biota half of the 4 principles. And by maximizing living roots, maximizing diversity, you can break pest cycles because of how resilient your system is, and as well as stimulate below ground diversity and increasing the soil organic matter. And that soil organic matter can increase your nutrient cycling and enhance plant growth. And then also bringing in diversity of different organisms, such as pollinator populations. So how do you feed how do you feed and maximize living roots? Primarily by making sure that it's always covered and always having something growing in it. You know, in Western Oregon, we don't have a lot of days that is not growing. We do get cold, but it still doesn't grow as much during the winter, but it does still grow. And by making sure that you're keeping that carbon infiltrated within those roots and feeding your livestock, the biology, and being able to provide that saltwater taffy with the livestock, you're keeping your organisms fed. There is a lot of information about cover crops, and by no means am I an expert. I do garden, but they're more in the form of rocks. So, but there is a ton of information out there that really can provide you a lot of information. But what I do know is it's very complicated, but you can find the right mixes for what you want them to do. And then there are different types of cover crops that can help with bringing the nutrients from below, like a daikon radish. You can use them to break up compaction, as well as clover can help provide nitrogen to the soil. So there's a variety of ways that you can use cover crops to enhance your system. So maximizing diversity is another one of those elements, or another one of those principles that help feed your soil. And as I was explaining my analogy of the different saltwater taffies, by having those different plants that will provide different sugars, which will attract all the different kinds of bacteria, which then that just keeps exploding of diversity, you can have a very diverse system. When you look out in nature, it's not just one species growing, there's multiple species growing. And that's how nature really can help make those stable soil aggregates and provide that habitat for those organisms. So now we're going to go towards explaining about protecting the soil habitat and organic matter. So maximizing the disturbance, don't maximize disturbance, sorry about that. Minimize disturbance. By minimizing the disturbance, you're allowing for the ecosystem or the habitat to stay intact, and you're maximizing, and then we're maximizing soil cover, and it maintains stable aggregates, as well as buffers temperature and reduces evaporation, and it also can help with weed pressure. So by minimizing disturbance, you can keep the disturbance within, some suggestions is to keep the disturbance within a local area. Disturbance can also cause compaction, and by avoiding and minimizing any kind of physical, chemical, biological type of disturbances. And like I said before, you can't just eliminate disturbance in an agricultural system, but you can be mindful about it. Here is an image that the blue is actually the pore space. This is a cation, this is a CT scan that is showing how the pores are full within the no disturbance. And this other image to the right is one time that there was machinery compacted at 14 years ago, and it hasn't been disturbed since. But the biology is coming back, but you can see that there is a difference. So minimizing disturbance is more of like picking what you want to do, when you're doing it, how deep you're doing, what kind of equipment you're using. That is primarily the way that you can minimize disturbance. And then also maximizing cover. You can use a relay covering, mulch, and it's just really providing a a protection on your soil. We love our soils, but we don't really want to see them. We want them to be covered year round. So it's more of a spectrum. So if you can do one thing, but you can't do another, that's okay. Everything really does help in order to be able to mitigate any kind of or increase the biology. It's all about scale and management. If you build them, they will come. It was just kind of one of the movies I thought was, yeah. So anyway, healthy soil is gold. Every step of the way is worth it. And the biology is already there. You just need to work with it. And I just want to make one point here is that there is within Web Soil Survey, there is a soil health interpretations that you can determine. I know that there is a biochar presentation later on. There is an interpretation for how your dynamic properties within your soil can respond to biochar. And with that, I am done. Thank you. And if you have any questions, I will take them now.
Thanks, Katie. That was fantastic. We can get a few of us on screen now. Maybe do you want to turn off your screen sharing so that we can do?
Oh, yes. Yep. Sure can.
Okay, wonderful. So we have so far just 3 questions in the Q&A window. Excuse me. The first one is, what makes a beneficial nematode versus a destructive nematode? Is there a difference, or is it just perspective? And the context is that this person works at a community garden and people complain about the moles, ground squirrels, insects, birds, and all the things that they perceive as destroying the fruits of their labor.
Well, I guess how to answer this question, there are different types of nematodes, and if they are causing a problem, I would say that would be more of a destructive nematode. And I'm sure there's different species that do kind of eat your crop. And I've heard when I was working with the strawberry nursery, we really worked hard to make sure that the nematodes were eliminated, but that's a completely different system. So there's a variety of different kinds of these organisms. Some will be destructive and some will not. I guess like when you think about the slug pressure here in Western Oregon, those slugs may not be terrible. They're decomposing in a forest, but they're not helpful within the agriculture system. So that's how I guess I really don't know exactly species wise, but there's different nematodes that will be destructive versus helpful.
Okay. And then I'll add my own follow-up question there. Do you have general recommendations or is it really species specific, like how to manage if they really are destroying your crops?
I would say you would have to figure out the species to be able to figure out how to handle them, because yeah.
Okay, sounds great. So the next question, this person is having a large amount of work done in their yard, and unfortunately that means that they have some heavy equipment crossing it repeatedly. So we're hearing a lot of compaction. And then once the project is done, compacting and churning, making treads and all that, what are 3 things that they can do to help the soil recover? Ultimately, they're trying to build a garden of native species.
Okay. So, breaking up that compaction is really what you want to start with first. And also adding, when you can add as much organic material as well, different types of plants like that daikon radish or things that will root deeply can also help break up compaction after you get something started. Any kind of machinery that you can, like tilling it up or giving that your soil a little bit more lift and not as much of a block. That would be my recommendation. And then once you can get plants started, then you can get more organic material in, and that will help eventually break up as you get more organisms coming in and burrowing in. That will also help with the compaction.
Great, thank you. Okay, so let's see. Now we have someone asking about ideas for winter cover crops in an area with a lot of below freezing points for a community garden.
I would just have to refer to experts on that because I'm not really super proficient on cover crops, but you know, OSU really has a very, if you look up the extension service, they have a really good website.
Great, thank you. Okay, let's see here. So we have a backyard gardener and they sprinkle compost over the top and then rototill using a steel power stick rototiller into the soil. Is this wrong?
Mixing the organic material in, I would say no, is not wrong. That's back to minimizing disturbance. And I mean, you can't, you know, you have to be able to mix it in, you know, and that's, I wouldn't say that that would be wrong, but, you know, in the future, as you go further and you have plants growing there, then minimizing that disturbance is key.
Great. Okay, let's hear it. So if we have, there's a home gardener asking about adding organic matter through soil amendments each year, even though their garden soil does not need it. Their soil organic matter content is above 5% and is the only harm done to their pocketbook and wallet, just from the expense of that, or does that make sense?
No, could you read it again?
Yeah, so I'll read it verbatim. If a home gardener keeps adding organic matter through soil amendments each year, even though their garden doesn't actually need it, because apparently maybe they've measured and their organic matter is above 5%, is it really just the expense that's the problem, or is there, do you have any thoughts about that?
Oh, like continue. So they have enough organic material, but by adding more, is it wasting money? Is it wasting effort? Well, I don't, you know, 5% is pretty good. So, and there's also you know, getting too much organic matter for certain plants is also not good as well. So I guess it would depend on which plants you're growing, because there are other plants that would really utilize more organic material and some that will not want as much. Mm-hmm. So depending on what you're trying to grow, I would say it could be a waste of money, or if you wanted if it's one of those plants that really does utilize a lot more organic material, then you wouldn't be. But 5% is a pretty nice number for organic material for most systems.
Yeah, that's what we've been hearing. Okay, wonderful. So next question, how do you manage a vegetable garden space near fir trees that contain a lot of roots every year, a lot of tree roots? It seems tilling the roots helps, but that is a disturbance, right? A recent soil test showed a low level of nitrogen.
Okay, so you have a lot of dug fir tree roots. Mm-hmm. And okay. Well, you know, my coworker was actually telling me about he's trying to grow lawn under his dug fir tree and he can't get it established. It could be a problem with pH, such as being too acidic for whatever you're trying to grow. And I mean, but it's the disturbance with removing the trees that's the concern. Is that?
Let's see here. So how do you manage near fir trees that I think the roots are, you know, the trees are nearby. There are a lot of roots there. It seems like tilling the roots helps, but the concern is that that's creating disturbance.
Okay. Well, okay, that's one of that spectrum, right? Where you want to utilize that land to grow something, and the roots are causing the problem. So in order to be able to get your crop to start growing or your garden, removing those roots is necessary. So that's one of that disturbance, that's that spectrum on how to manage your system and what you want to do. So I would say, you know, if it's, don't disturb it while it is wet, because when soil is wet and you compact it, or when you disturb it, it can get compacted quicker. So you want it but you also don't want it too dry either. So you want it in that Goldilocks period of when you do disturb it.
Great. And then one other participant suggested perhaps doing raised beds instead, if that's an option.
Oh, yeah. Yes, that's a great, yes. Thank you, participant.
So we have one last question. If you keep healthy roots and cover crops in your garden continuously, should you be adding nutrients, or if done right, can that ever be avoided?
Well, by adding having the living roots, so there's a lot of, we're watching a lot of videos about how they do the relay cropping, where you have your cover crop, and then you're actually planting within that cover crop, and then they grow. That has produced really good product, at least from what I was watching from some actual people doing this on YouTube. And so it's actually providing more material, more organic material year round. And okay, I lost my train of thought there. Can you read the question again?
Sure. If you keep healthy roots or cover crops in your garden continuously, should you continue to add nutrients? Or if you've done the cover cropping correctly, do you need to keep adding nutrients?
Well, I guess okay, so if you did the cover crop and then you plant your crop, your cash crop, the crop that you're interested in, if you're starting to notice that there is issues, I guess I would say that you could add whatever you needed to add to make that. So if it was low in nitrogen, maybe its leaves started turning yellow, and you started recognizing that this is a low in a nutrient, I would say do what you need to do to add that nutrient that it might be lacking. So that would be, the amount that you need to do that for, but not minimizing how much you need to add. But so I wouldn't say that that's a bad thing to, if your plant isn't growing the way you want it, that mitigating and making sure that it does grow, I think is a good option.
Great. Thank you. That was the last of our questions. So thank you so much. And thank you to everybody who has attended tonight. It's really been wonderful to have everyone here and all the great questions. We do have a survey link, which I will just post in the chat right now. So please take a minute. It'll just take a quick second to say, share your thoughts on what you thought tonight. And we really look forward to seeing everybody on Tuesday for the next session. Hopefully everyone signed up for the next one. So thank you, Katie, again, very much.
Thank you. Thank you. Thank you for having me. Bye.
Cool. Bye.